Here we go. All right, so the midterm. So the first thing, I gave you this function and asked you to run it. And then I said, all right, now use that function to download all of the data from 2014-15 to 17-18 and bind it into a single data frame using a single function. So one line of code, right? And so that should be mapdf, right? Or DFR. And so all we're going to do is just load the tidyverse. That's going to load per, which you can see here, right? Per for me 0.3.4. And then we say mapdfr. We say the thing that we're looping through, the years 15, 16, 17, and 18. And then we apply this function, download file, save that to D. It will then go out to the web and download each of those files and then bind them together in a single data frame. Okay, so this takes a minute as it goes and gets each file. And they're, you know, relatively large, not huge, but maybe I should have run this first, so we don't have to sit here and wait, but shouldn't take too much longer. There it is. Okay, so then that looks like this, right? So I don't have to use an ID or anything because we already have this academic year column in here. Otherwise, I probably would say .id equals year, and it would just insert, well, it actually would just say 1, 2, 3, 4, because these aren't named. But I could name this vector first, give it names, like 2015, 2016, 2017, and then it would put that in the academic year, right? But because I already have that column here, I don't really need to do that. Okay, so then I said conduct some basic data cleaning to make your data look like what I showed in the lab. So specifically, you're going to do these things. Filter for only student groups coded white or Hispanic Latino. So I have D. I'm going to go ahead and just use janitor to clean the names. And then I'm selecting some variables first. So I put this as the second thing, but select variables related to the number of students in each of the levels, 1 through 4, and not percentages. Okay, so if we look at this D, we can see we have percent level 3, or number level 2, percent level 2, number level 1. So I want only the number ones. And then we also have these like participation rate, and then we have these like collapsed ones. Number proficient level 3 or 4, percent proficient level 3 or 4. Okay, so we didn't want those. We wanted just the number, the number of students associated with each of the levels, 1 through 4, and not percentages or collapse levels. Okay, so that's what this first part is doing, cleaning the names and then just select those variables. So that ends up looking like that. And then we go ahead and do this first part, filter for student groups coded as white or Hispanic Latino. So where student group is equal to white, or student group is equal to Hispanic Latino. Okay. So then we have that. And then it says remove any rows that have missing data in any of the n variables. Okay, so I'm just going to say drop NA for number level 1. In this case, if it's missing on number level 1, it's going to be missing on any of them because that's how the cell size works, right? So you could have said number level 1, number level 2, number level 3, number level 4, and that would be the same thing. I just put the first one. Okay, so I do that, and then we get this. And then I didn't tell you to do this last part, but it should have been fairly obvious by looking at the data that you then need to move from this wider format. So let me move this out of the way so we can see it a little bit better. So we have it in this wider format like this, right? Number level 1, 2, 3, 4, to this longer format where we're going to have a new column called level and a different column called n. Okay. So the way I did this is I said, okay, give me all the columns that start with number, which is just going to be these ones. And the names are going to go to level. The name's prefix is number underscore level underscore. So that this whole part, right? That's a prefix for all of these. So I'm going to basically just drop that out. Okay. And then the values are going to go to n, and the value p types, this is like the type that the value is. For n, I'm just going to say that's going to be an integer. Okay, we could do that in a mutate afterwards too, and that would be fine. but this is a way to do it all within the same thing. Okay, so then we end up with something that looks like this: academic year, district, school, student group, grade level, level, N. And then this last part, I'm just arranging it by a few things. Okay, so then we end up like this. All right, so that was that first part. Any questions on that? Okay, and of course, there is more than one way to do that. So if you did it slightly differently and you came to the same result, that's fine. All right. Okay, second one. Now I'm saying sum the N across grades and school for each district within each academic year. So that means you're going to have a year and district for each row is going to have a year and a district, right? So district is going to be repeating, and you're going to have a year within each district. And then you're going to sum the N across grades and school. Okay, so the multiple rows, if we look at D right now, okay, the multiple rows we have right now for grades and for school, we're going to collapse all of those. So we then have one row for each district for each year. Okay, and then across grades and schools for each district in each academic year, student group and level. So we'll have a row. One row will represent a district within an academic year for a student group and a level, 1, 2, 3, 4. Okay. Calculate the number of unique schools as part of this calculation. Okay, this was a part a lot of people struggled with. So I'll show you that in a second. But basically, as you're doing that calculation, I want it to sum the number of schools within that district that are unique, right? Because we don't want to say how many rows are there, because that's not going to be the number of schools. We want to know how many schools are in that district. And then also move your data to a wider format where a student group becomes a new column filled by the district N. Remove districts that did not report numbers for one or both student groups. And then your data should look like this. Okay, so we're going to start out like this. I'm going to group by district, and I'm going to say mutate N schools is equal to the length of unique school. So here's my school, right? And so the first thing I'm going to do is calculate that variable right here, right? Calculate the number of schools. So all I'm going to do is I'm going to group by district, and then I'm going to say, what's the length of the unique schools? Okay, so you can think of group by as essentially splitting the data frame, right, for each district. And then for each district, we're going to say, how long is a vector of unique schools, okay, for that district. And so what we end up with then is something that looks like this, right? And so I'm only looking at one district here, so you can see in schools just is constant. Okay, so 2, 2, 2, 2, 2. Then there's multiple ways we could do this, right? Probably the way that most of you did this is to actually say group by academic year, district, student group, level, and schools, and then summarize where the N is equal to sum of N or whatever. Another way you can do this is to just count each of these, okay? And then you can apply this additional argument, weight, okay? So I'm going to weight my count for each of these things by the N, okay? So this is the same thing. So if I do this, right, I get something that looks like that. That's the same as if I said group by these things, and then summarize where N is equal to sum of N, okay? So if I did that, that would be the same thing, okay? Either way, those are the same. This way is probably more along the lines of how we've done it before, but I kind of wanted to show you count is, I think, a pretty powerful function, and especially if you combine it with this weighting thing. So your counts are going to be basically weighted by some N variable, okay? So that gets us here again, and then what we're going to do is we're going to move it wider now, where student group becomes a new column over here, and we're going to fill it by this N. All right, So I'm going to just say the names are from student group and the values are from N. And it looks like this. And now I'm going to go ahead and say janitor clean names to clean up these again. Okay, that's optional. Obviously, you don't have to do that, but it's an easy way to fix those names, to make them nicer variable names. And then I'm going to say drop NA from Hispanic, Latino, or white. So any row that is missing on this or here on either of these two variables will be dropped. Okay, that row will be dropped. And so I do that. And then finally, I say, okay, just ungroup and then give me the academic year, the district, the in schools, the level, and then everything. So this is just another way. This is just a way to rearrange things, basically. And there's our final data frame. Yep, Chris?
Could you re-explain that weight thing? Because I was really wrestling with trying to do this in like a way without doing a left join, and I got it with a left join, but I have no idea what that's doing.
Yeah, so it's basically like this, right? So I go data dot, or I'll just do tibble, right? And I'll say v is equal to letters 1 to 2, 3. All right, so there's my data frame. And now I'm going to say count is equal to, and I'll say 5, 7, 3. Okay, so here's a data frame. Now, if I say count v, actually, let me make this a little bit better. Let me rep that twice, and then I'll make this twice as long too. So then I'll go 1, 2, 1. Okay, so there's my data frame, right? So ABC is repeated, and we have count that looks like that. If I just say count v, it's just going to say 2 for all of them, right? Because A, B, and C are each represented in this data frame twice. If I say count v and weight it by count, then it's going to do 5 plus 1. A is going to be 6, right? If on B, it's going to do 7 plus 2, which is 9, and C is going to be 3 plus 1. So then I end up like that.
Okay, that makes sense. Does this work? Is this like a powerful thing in any other context besides this like exact type of summing thing? Because it seems, I imagine if they implemented it, it is, but I can't see any other way that it would be useful.
Yeah, I use it a lot, honestly. It's anytime, so I use count a bunch, right? Just to get like the number of things. It's a quick way to get like how many unique instances are there of specific things or whatever. But very regularly, you want to do things like, let's say, you know, you want a count by school and grade, but then you want to weight it by how many kids are in specific categories like LD or whatever, right? So it's just a way to, when you're summing, instead of summing 1, 2, 3, 4 each unique count, it just sums according to some other variable.
Okay, thank you.
Mm-hmm. Any other questions? Okay. All right. Then this next part, I know at least one of you had a little bit of issues with this. This is actually, it's not related to with installing this. The install problems, at least the people I worked with had problems with this. It's not actually related to the package. It's related to GitHub updating the way that they are requiring you to be able to install packages from source from GitHub. And they have this new authorization approach. So if you run into that, if you didn't run into it here, then you're probably good. If you did, then hopefully you fixed it. But if you didn't, there's still a chance you may run into it later if you haven't updated to the latest ways of handling this. So I can send more information about that if you want, but basically you have to use a GitHub pat for this OAuth authorization thing. But basically, you should be able to download this package from GitHub. And then I was asking you to run this estimate v function. So here we load the package. And then the only reason I have this 1 through 4 here was to say, OK, so here's for 2014-15 for Adrian School District 61. And we want to estimate v here. So I'm going to estimate v where the data that I'm estimating V for is this data here, right? And we have white and Hispanic Latino, those are the two columns. And when I run that, I get a data frame in return that has this AUC, V, and VSE, okay? But this 1 through 4 is just to say that's for the first school district for the first academic year, right? So I could also, let's say 5 through 8, okay? And then I would get that. So here's 5 through 8. It's going to be for Adrian School District for 2015-16, and then we get those. So what I'm asking you to do is to do this for every combination of academic year and district, okay? That was what I was looking for there. So that's this point. Estimate the average achievement difference in terms of an effect size, that estimate V, for every school district in the state that reported data on both student groups for each academic year, okay? And then conduct this analysis twice, once using group by nest map and once using nest by summarize, okay, since we talked about both of those methods for doing this, okay? So I have Gapper loaded already. The first way that we talked about first is take D, we're going to group by academic year, district, and in schools, and then we're going to nest, okay? So that's going to end up looking like this. So we have here's for an academic year and a district and the number of schools, and then here's the data. Okay, now I'm going to create a new column in this data set that loops through data and creates that and runs that estimate V function. Okay, I will, just for the purposes of illustration, time these things too. So there's this package called TikTok, which will allow you to do really easy timings where you say tick and then you run some code and then talk, and it will figure out how long it took to run the code between those things. Okay. So here I have by district. I'm going to mutate to create a new column to this data frame, which I'm going to call models. Okay. I'm going to map, so I'm going to loop through data. And for each of these datas, I'm going to apply the function estimate V. Okay. Then these are additional arguments to estimate V. I could just as easily, right, use the tilde syntax. And then it would be estimate V dot X is my data. And then white and Hispanic Latino are the arguments to that. Okay, that's the same thing. The other thing I could even do is I could do dot X and then pipe to estimate V right within here and then go through there. All right. So in this case, dot X becomes the placeholder for data. All right. So all of those versions are the same thing, and it's just whatever you feel most comfortable with. All right. Then I say select minus data. So I'm going to drop this column altogether, and I'm going to say unnest models, which will then give me the data frame for each of those. Okay. So let me just run this part first so we can see what that looks like, although it's going to take a second. Taking longer than I would have hoped. Maybe I shouldn't have done this. All right, maybe I shouldn't have done this. The only reason I was doing this was to try to show you what this data frame is going to look like, right? And it's going to look just like this, but it's going to have another list column here called models that just has a list column like this, and it'll be a tibble just like that. And we do get this warning, which I think I mentioned up above, that we'll get this warning about couldn't invert the Hessian. Okay, so I'm not worried about that because I'm not worried if these estimates are actually accurate, but this is what it ends up looking like, right? And so each of these models is just a one row data frame. And so when we drop data and we unnest models, then we just get a regular data frame that has all of the information with models. Okay, so I'll run this with TikTok, and that should give us the results for every academic year, for every district in our sample. Okay, and our sample is not every school in the state, right? It's every school in the state that had data on both groups, which is not all of them, because if they had too small of a number of students in one of the groups, then those were omitted, okay, for privacy concerns, so you couldn't identify an individual student. Okay, as that's running, I'll go ahead and talk through this one. This one is going to be basically the exact same sort of thing, but instead of saying group by, we're going to say nest by. Okay, when I say nest by, so there it is, it took 47 seconds. Okay, so here, and let's actually look at this now. So now it looks like this. Okay, so here's an academic year, each academic year in districts, right? So that's the key of this data set, these two variables. We have the number of schools, and then the AUC, the V, and the V standard error. Okay, any questions on that? Okay, so for this nest by part, this is going to be very, very similar. We're going to take D and we're going to nest by academic year, district, and then schools, but that's going to turn it into a row-wise data frame. Okay, when I use nest by, it automatically turns it into a row-wise data frame. And so now we have the same groupings as before, academic year and district. These are just sorted differently. That's the only difference. And then we have the data here. So now I'm going to summarize rather than mutate. And I'm going to say create a new thing called models, which I'm going to estimate V data, white, Hispanic, Latino, right? That's going to be the same thing. This is going to give me a data frame in return. And then I'm going to mutate. V nest by is equal to models V, so I'm just pulling out just V and then select minus models. Does that make sense? So I could run this line by line if you want, but it just takes a while. And I will post this after class, so you can run it line by line too if you'd like. But any questions on that? Okay, so these two things, this code here, 166 to 169, and this code here, 173 to 177, should give us identical results. They're basically identical approaches. They're just using slightly different syntax, and so we end up writing the code a little bit differently, but they're doing the same thing. Okay. So we'll hang out just a second. 47 seconds again. We get a warning about inverting the Hessian again, but that's fine. Okay, so mods nest by looks like this. So we have only V here in this case, and we could have taken all of them if we wanted to, but I took just V nest by. So up to you how you do that. Okay. If I wanted to, I could have surrounded this in a list too. If I don't, then I think I get list columns. So it's like models $V, $V, yeah. So that, yes, so that's what that is right there, right? So either of those works fine. All right. So then I wanted to verify that the results from those two methods matched. Okay, so I have mods nest by, which looks like this, right? And then mods, which looks like this. And I want to just verify that this V for a given academic year and district is exactly the same as the V for this data frame for an academic year and district. Okay, so all I'm doing is I'm going to join those two things together. Okay, and they look like this now. V nest by. And you can see just visually here they look identical, so that's good. But I'm going to plot all of them just to make sure. So I'm going to pass this to ggplot. Put V nest by on the x-axis, put V on the y-axis, and then do geom point, and then geom line, and it looks like this, right? So that's good. And then the rest of this is just like some styling stuff, okay? Putting the axes on there and whatever, axis titles. Questions there? Okay. Next, we are going to plot the achievement difference estimates for one school district, or for all school districts. But this is showing for one school district across years, okay? And we're going to produce a similar plot to the below for each of the first 100 school districts, okay? Once we've created all of the plots, we're going to reproduce them again using an alternative method. I said alternative because you don't have to use nest by, right? You could also do like some for loop method or something like that. So it's more up to you what your alternative method is. I used map and then nest by. Okay, so here we go. I said hint, you need to select unique districts. You may want to try something like the following. So here's dists, right? And I'm saying, give me the unique districts from V, right? Oh, except I don't have V. And then, let's see. And then, model list object. So I didn't actually, this is like dummy code. Okay, but here's for an individual district. Let me just run this so we can look at it real quick. So here I'm just saying Bandon filter V, this thing I just created right here, right? Where district is equal to Bandon school district. Okay, cool. And then we produce a plot like this. So here's what Bandon looks like. This is right just for Bandon. And there's, again, numerous ways you could do this, but this is how I chose to do it. Take Bandon, and I'm saying as.numeric, as.factor academic year. So basically the x-axis is going to be numeric. And then putting V on the y-axis. Okay, so we've got academic year here. I'm converting this to a number, and then I am putting V on the y-axis. So that ends up looking like this. 1, 2, 3, 4, and then there's V. Geom H line, I'm putting a horizontal line at 0, where the y-intercept is 0. Right, that looks like that now. So that's cool. Geom line now for the x and y axis, where the color is gray 70, and it looks like that. Okay, so here it was in the first year, second year, third year, fourth year. Adding a Geom error bar. So again, if we look up here, we can see we have this V standard error. So I'm doing Q norm to give me the lower and upper bounds of that. You could also just do 2 times VSE or 1.96 if you wanted to be more specific. This is being overly specific, right? This is negative 1.96 basically and 1.96. Okay, and so we do that. That gives us our error bars. And then we're going to layer some points on there. And notice I have color equals directionality here. So up here, when I was creating this, I created this directionality variable. These are just changing the name of the district so that they look a little nicer, right? But for the directionality, I said if V is greater than 0, then put this string. If it otherwise, put this string. Okay, so here's directionality. You can see it's one color here, and then it's a different color there. Okay, so I will do that here where I'm saying color is equal to directionality. Now, when I first do that, it's not going to give me the colors that I actually put in there. To do that, I have to use this scale color identity. So it's going to say use whatever the value is that's in the column as the color, and that creates that. Okay, and then scale X continuous, the breaks are 1 to 4, and I'm going to make the labels the unique academic year. So that's going to change 1, 2, 3, 4 to the actual years. And then finally, just some cleaning up with the labels. I'm using GG text, so that's how I'm making these spans different. And there you go. This didn't work. Maybe I didn't actually load GG text. It's not working for some reason, but it does when I render it. So I don't know what's going on there. I think, yes, I do know what's going on there. I think I need a theme on there where I would say plus theme plot dot subtitle equals element markdown. There we go. So that's a GG text thing to get this to say white and Hispanic Latino. I think I said though, oh yeah, no, never mind. So like yours didn't have to be exactly identical to this, right? But it should have been close-ish, all right? Okay, so how do we do this for all of the first 100 districts then? So there's basically 2 different methods, pmap or nest by. Okay, so here's the PMAP method. First, I'm going to create just the districts for the first 100 districts. So I'm going to say the unique V districts. So V is still this thing I created up here where I took my mods, cleaned up the district name, then created this directionality variable. Okay, and so when I say what are the unique districts, this is just the first 100 districts, right? So this is just a character vector. Okay, then I'm going to say filter where district is in dists. Okay, so district in V, when I look at V, this district column, this value is in this dists vector. Okay, that gives me the first 100 schools. And then I'm going to nest by district and in schools, right? And I get something that looks like this. Here's the district. Here's the number of schools. And then I'm going to mutate where I'm going to say PMAP. I'm going to create a new column here for plot. PMAP list, I'm going to loop through the data, the district, and the in schools. Okay? And then I chose to do function.d.district.in schools. You could also refer to them as .1, .2, .3. Okay? But then when I write my ggplot code, it's going to be the same as above, but I just swap out data with .d, right? And then down here, I say achievement gap estimates .district, right? And district included .in schools in schools. Okay, because that's going to make this number here change and this title up here change. Notice this is with glue. You could do the same thing with paste 0 or whatever. Okay, and then I have this element markdown part, and we should be good to go. Okay, so I create that, and now we can look at this plots thing, and it looks like this. So here's the district, the end schools, the data, and then the plot for that district. So that's all of the plots for the first 100 schools. The nest by method is going to be quite similar. We're going to take V, I'm going to ungroup it first, filter where district's in dist, then I'm going to nest by district. Okay, so that looks like that. And then I'm going to say plot list, right? Because anything that doesn't return a single vector, we want it to be a list, ideally. I'm going to call ggplot, and I'm going to say data, right? So this data on each of these is what I'm going through. And now the rest of this is truly just what it was before. Glue with district, right? This thing over here. And then districts included, unique data in schools. Okay, so I'm just calculating the number of schools there. Or no, I'm grabbing the in schools column from there. I could have also said nest by district and in schools, and then I wouldn't have had to do this data $ thing. Okay. Other than that, it's going to be basically the exact same as before. So we have plots 2, and it looks like this, basically the same as the other one. Okay. And then finally, I think I said for 1 point extra credit, go through and put those things together. So I used patchwork, and I said, okay, take plots plot and plots to plot, and then apply the function plus. Okay, so this is with patchwork, right? You can say plot 1 plus plot 2, and it'll staple them together like that. So now I'm going to do that for every single plot, okay, all the way through. So I'm calling this EC plots. I don't know why I'm calling them EC plots. I don't remember why. But it made sense at the time. Okay, so here's EC plots 4, right? You can see they look the same. They're kind of overlapping over there, but that's fine. Here's 24, right? Here's 32. So I'm just picking some random numbers to look at these, and 67. So they look the same for all of them. So that's cool. All right. Any questions on that? Yep, Chris?
Does this work when you knit? Because I got some problems using cowplot, and then I tried it with grid extra as well. And when you knit it, it like doesn't work, but it works just fine when you don't knit it.
I didn't have any problems with knitting it, but actually I think I have this set eval equals false. So I'm not sure. I have not run into issues with that in the past, but I don't know. I'm not sure.
Okay. I'll look into this package if I ever do that again.
It's, I think actually Patchwork and any package that puts plots together is super nice, because I end up in publications fairly regularly, probably not surprisingly, having a bunch of plots that I want to show. And so I can often put like 3 plots together, like 2 plots up here and 1 down at the bottom that kind of spans the whole distance. And that's all figure 2, you know. So it's really like 3 figures in 1, but they're all sort of getting at different versions of the same thing or whatever. So I think Patchwork is a super nice package. Okay, last part. Basically, now you've got all your plots, so go ahead and save them all in a directory. So here I have this dir.create. You could use fs dir underscore create, I think is what it is. And I'm saying create a directory in here, content post, which is where I'm at in my website directory area. Take home midterm plots. Okay, so I'll run that, and I'm probably going to get a warning, yes, telling me that it already exists. Okay, so I don't care in this case though. So now I'm going to say, okay, there's lots of ways to do this, but if I look at plots district, right, it's like this, right? And oh, this is probably not going to do what I was thinking wants to do. Yeah, so I actually already fixed this up above. This was a way to pull just the district name rather than school district. So I've already actually fixed all these names, so that's not going to do anything there. But then this part will. Okay, so I'm going to say, give me all of the spaces and replace them with underscores in dists. Okay, and then after that, I'm going to say to lower. So it's all going to go to lowercase. Okay, so here's what my dists look like now. Reynolds School District, Reedsport School District. Okay, and I'm doing this because I'm creating file names. So now I'm going to say, okay, for files, glue or paste 0, it's fine. Achievement gap underscore dists.png. Okay, and so that looks like this. Okay, so this is just each file name. And now I want to build the path to there. Okay, so now I'm going to say, all right, here, content, post, take home midterm, plots, and then I'm just saying files, this whole vector. So here will allow you to paste a vector in there like that, and it'll build all the paths. So now files looks like this, huge thing, huge path, right, with different file names for all of them. And then finally, I say, okay, walk 2, loop through this files thing, and loop through the plot that I want to save, and apply the function ggsave. That's it. Okay. These additional things are additional arguments to ggsave. Make the width 6.5, make the height 9. And when I do that, it takes a minute, and it goes through, and it's going to give me this message a bunch of times. But it saves all of the plots there. Okay. This is, again, something I do super, super regularly. Create directories and save a whole bunch of plots in that directory, or write out a bunch of data files, 1 for each grade or 1 for each whatever. Okay. So that is it. Questions on that? I want to mention, I know that this midterm was challenging, right? It was supposed to be challenging. It's asking a lot, and there's a lot of open-endedness, but this is very much like a real example of when and why and how you would use this kind of stuff. So even though it might have felt like you sort of got thrown in the middle of the ocean and I was asking you to swim back to shore, it is very realistic. So if you struggled with it, that's fine. That's part of it, right? But hopefully you got a feel for like, oh, this is why we need to do this kind of stuff, right? Okay, any questions on that? Okay, so I'm going to switch my share to here, and then we will go to lab 3, which is here. So we have part A and part B here. Part A is just this foundations part. hopefully it should go pretty quickly. You can find the information in the slides if you look. Name, describe the 3 fundamental components of a function, and then describe 3 different ways functions can be stored/applied, and an example of when you might want to use each version. Okay, so if you look back at this, you'll see that's in the slides as well. But yeah, there's one in particular that's like a little bit tricky. But there are 3 different ways that we talk about functions being stored/applied. Okay. All right, then the applied practice part. So this is how we define the mean, right? And it's basically we're gonna sum a bunch of things and then divide by the total number of things. Okay. So what I'm asking you to do in part 1 here is write a function to calculate the mean, but your function should remove missing data first. Okay, so your function should remove the missing data. Then, and you may not use base mean in your function. Okay, then what I would like you to do is test your function to make sure it provides the expected results. Okay, specifically, you should make sure it gives identical output to base mean when you have na.rm equals true. Okay, and make sure when you're doing these tests that you test it against a vector that has some missing data so you can make sure that your function is working. Okay. Next part, I'm saying I'm giving you the code, right? Here's the code for 3 different things, and then we have a little description of what they are. So this code will count the number of missing elements in a vector. This code will give you basically the proportional representation of a vector. So like in this case, we're looking at cylinders, and we're saying that like there are 20% 4-cylinder cars, 50% 6-cylinder cars, and 30% 8-cylinder cars, or whatever. That's what this would do. Okay, so it's giving you the proportional representation of cylinders in this case. Okay, so and then this last one is basically creating a z-score vector from a vector. So what I'm asking you to do is, here's the code, right? And I'd like you to generalize this code into a function. So basically, take this code and put it into a function so it can be applied to any vector. Okay, so you're going to have to think about the arguments to the function and how you're going to modify this code to make it actually work in a function. Okay. Write a function that takes a data frame as its input and returns a data frame as its output, but that data frame only has numeric columns. Okay, so you're just going to drop any columns that are not numeric. And then finally, write a function that uses this function and returns a data frame with the mean and standard deviation of each numeric column. Okay, so you're writing a function in question 4 that you give it a data frame and it returns a data frame, but that data frame in return has only numeric columns. Okay, then in the 5th one, you're going to use that function in your new function that calculates the mean and standard deviation of each column in that data frame. Okay, so that's it. And we have less time left now than I was kind of anticipating we would. So I am kind of walking back what I said earlier about if you work on this the rest of the time, you should be able to be done. But you do have a bit of time, so like 35 minutes or so. So you can go ahead and get started on it and let me know if you have questions as you go. Okay. Any questions that jump off right away?
I have a question on part 3. You have this like per map double call. Are you wanting our function to have the split be like this? It's always going to be the same vector for all 3 of those, or are you wanting it to be able to be like split by something different? Do you see what I'm saying?
Just this, yeah, just split by the same thing. So all you're going to do in these cases, you're not going to extend them to be more general. You're just going to basically take exactly this and make it a function.
Sweet, thanks.
Mm-hmm.